Okay. All right, so today we're going to finish up the design process, and this is going to be a really fast trek through that. Just want to highlight some key tools or strategies you might use through the remaining part of the design process. So this is the fourth of the 5 required lectures. Next week we're going to talk about ethics. And so I need you to complete that survey before you come to lecture, because we're going to talk about some of the scenarios that you're going to encounter in that survey. Okay? The link is also it's in my EPICS now. It's also on the Teams page and announcements, so you don't have to try and copy down that link exactly. But I wanted you to have at least a reminder of that. And I will also be emailing it out. And we're also going to do ethics discussions kind of in our labs after next week. Okay? All right. Specifications. Who has some specifications from their projects? Who had trouble finding specifications for their projects? Okay. Yeah, that's probably a little bit of an issue. So it is something that, especially if you're new on a project, that you can ask about, because it's absolutely key. As I had indicated before, certainly this is a starting point for a lot of the design reviews. So design reviews are in 2 weeks, okay? That will be your starting point for your reviewers to say, what is your project supposed to do? How do we know if it does that? Okay? So when you think about specifications, they need to be quantifiable, so measurable and testable. How will you know if your project meets its specs? Okay, you need to have some kind of criteria. So saying something as light, depending who you are, your definition of light might be very different than somebody else's definition of light. And or especially if you're thinking about light for how long. You can carry something very heavy, maybe a short amount of time, but if you have to have something that you're doing for a long period of time, it actually can be cause physical damage. I know the GDAT team, one of the things they're looking at are kind of implications of testing devices used for a very long period of time. So, really thinking about that. Based on some metric usually. So there's either some benchmark data that you're looking at to determine this. Maybe it's the current status of what the project's able to do that you need to improve upon. Or maybe there's some standard out there that it has to meet. Okay, so being really able to look at that. And of course, units, associated with that. So when we think about specifications, there's actually a wide variety of categories of specifications that you can develop. So there may be some physical specifications. What size does it need to be? Certainly functional or operational. What does it need to be able to do? Environmental. Are there aspects related to that have an impact that it needs to adhere to? And that might even be noise limits, on it. Economic. Are there certain criteria, cost ranges that you need to stay within? Legal. Again, are there certain standards, regulations that it needs to adhere to? And so are there specs associated with that? And then human factors or ergonomics. So some of the things even talk about easy to use. Certainly as a characteristic that might be desirable for your project, but how do we define that? So you might look at doing how many errors did they have within a certain amount of time? Or how long did it take to do it? So there are aspects, a way to quantify a lot of even the human factors or their ergonomics related to that. The other part is that we'll talk about too, as far as using information that gives averages of, for example, even heights of people or length of an arm, so that we can use that kind of information in doing design. Okay, so there's a whole bunch related to that. And actually a universal design calculator that can show you how universal, what percentage of the population can participate in using the design. So just as an example, I think this is used in the design process. So one of the projects that the glass team had worked on for a while was the talkie board. It's been replaced by the Herd. But originally they came to us and they wanted this device. There was something like it on the market, so they gave us a benchmark, except the device that they had on the market is that you basically had to program the sound for each slot individually, and then that also would, it was not interchangeable. So if you mixed up the cards after you programmed it, it would say the wrong thing when it was being communicated. This is especially problematic for people with disabilities because as difficult as it is to learn something, it's even harder to reteach something that you've taught incorrectly. So being able to make sure that it didn't make that mistake was really very key. So they came to us and had some things, and we could look at the market to be able to do that. They wanted 4 cards, and they wanted us to be, no matter where we put the cards in the slots, that if we programmed that card to say banana, when we put banana in the slot and either put it in or pulled it out, it would say banana. Okay, so those were the general requirements for that. What we started to do then is actually break down those to very measurable things. So there were some things that were they were specified. They wanted 4 cards to be displayed. But then we needed to explore more specifications on how many cards possible did you want to be able to include in this system. How long is the average utterance? What volume does it need to communicate at? Do we need to be able to vary the volume? So a variety of different specifications for that. So as we started with a broader need or requirement, we started to identify very specific requirements. So this is a strategy you can use as well for your projects to be able to break this down. As I said before, benchmarks, why it's important. Because first of all, we want to see what's commercially available out there, because if there's something already available that meets the need, then we probably won't need to be doing that in EPICS, okay? So we also want to find out why they use the approach they did that can inform our design and actually maybe give us an opportunity to innovate there. We also want to do like patent searches to make sure we're not infringing on any other IP for that. And we want to then be able to identify what do the current products, what's missing? Why is our community partner coming to us with this need? Because what's not being met by the current available products for them. So one way to organize, it's always good to kind of put some of this information in tables or have it so that it's captured so that you can capture kind of key information about this and often refer to it. Even though it's good to have narrative around some of the specifications on some of the motivation, when it comes down to doing your functional test, you really want to be able to know what's going on here. One of the things that's key to also include is the origin of your spec, because sometimes things change. So I've heard of projects and I've seen projects that have these legacy specs that are no longer valid, okay? So really making sure that you understand that it was based on a particular regulation, maybe that changed, so that, or maybe some particular person's preference. Because if somebody else is involved in the conversation, then that will actually influence your specification. So it's always really good to capture that. How will you know if you've achieved it? So some people think it's kind of crazy to think about how you're going to test your project before you have it designed. But actually thinking about that initially can really inform your design and make sure that you have designed into your project ways to assess whether or not you've met it. So you can actually inform your design with some of those things. So it might be a standard test that you would do, but it's important to even think about that as you're beginning the project. And then you can use this to say, have we met this spec as well as you go along? So for example, if I wanted to look at, maybe if a sound is audible in the classroom, that would be my general requirement. But then I would need to go and see where does the dB range need to actually be? And where did that come from? That came from our project partner. So these are things that you would be able to do. If you say your project needs to be educational, perhaps you would do a pre and post test to see whether or not students learned as a result of that. So you can start to be thinking about the broader things that are needed of your project as you fill out this specification. Another example here that can be kind of an example of a list of specs that it actually, and you can see it's very quantifiable. Specific voltages, how many hours of performance, what is the efficiency related to this. So these might be how your specs look for your device as well. But really, again, trying to capture the key information for that. So the goal of the specification is to understand, again, what is needed. We haven't really talked about how to implement any of this stuff yet, have we? Maybe you have some ideas, but specification, you really want to get at what is needed by your design, not necessarily how to do it. And part of the design process is to get approval from your community partner on these specs. Why is that probably a good idea, right, from a human-centered design approach to get buy-in? But what are some other benefits of getting your community partner to come to agreement on these? Any thoughts? So if you've had a conversation with somebody and I repeat it back to you, we check for understanding, right? To make sure we're all on the same page. The other thing that's really key is if you can get agreement on this, this will at least minimize the opportunity for scope creep, which is a really number one probably kind of situation in design that will lead to your not being successful in delivering your project, okay? It's easy to want to include everything, every cool feature in your design. But in order to kind of be effective in the design process and to actually just be able to meet that goal, you don't want to be changing what you're doing throughout the design process. You're not going to be successful in doing that. Then you have to go back and redesign. So if you get agreement, first of all, you know that this is what your community partner meant by saying it was lightweight. And then also this is an agreement that you can have that can kind of prevent scope creep. Okay, so very, very, very important aspect. Industry, we talk about that all the time about, minimizing scope creep. Yeah.
Can you tell us what scope creep is, please?
Oh, scope creep. So what happens is you scope a project, right, to have certain capabilities or boundaries. Scope creep is that when you start maybe adding features to it or make it more complicated or change some of the direction of the project. So maybe initially you just say, we're going to do a website, it's going to serve this many people, no database required, and then all of a sudden you start talking and they add features to the design request. And so that's the scope, how you're defining your project actually then gets larger, it creeps, okay? It's one of those things too that it's not always, it's those one items at a time that add up and make it, can have a real detrimental effect on the project. Okay, all right. So the next phase is the conceptual design, and this is the time where we're using that divergent thinking and then actually convergent. Because if you see, you start with a lot of brainstorming and kind of another is like widening that design space, increasing the design space, but then actually narrowing it to at least a few feasible solutions moving forward. And we'll talk about a few of the things that we can do. So one of the strategies, so expanding that design space, because often we might be starting here thinking about our design and we might have this different idea, but the optimal solution is maybe out there. So how do we expand the range of solutions that we're considering to include the optimal? And that's why we use a lot of the brainstorming techniques with that. Another strategy is doing a functional decomposition, and this facilitates different brainstorming. So going back to the glass device, part of it was understanding what were the different components, what did they need to do? And then you can actually brainstorm different solutions and combine them with that. So you break it down to the purpose of the system and then and keep breaking that down. So an example for the talkie board, we needed to identify the cards, was one of the functions that our design needed to be able to do. And so we could actually then brainstorm different ways to do that. And then it needed to have like a mode selection with this or play sounds. So these were things it needed to be able to do. And so you can come up with different solutions and then try and combine them in ways that are innovative or unique or efficient with that. Okay? So this can get you out of the mindset of you have a particular solution in mind. If you think about a solution for different aspects, it actually might help you come up with a more innovative way of thinking about it. Some of the other brainstorming strategies is to be able to do like Scamper, where you use a lot of analogies or make changes to current solutions to maybe try and come up with something that's more innovative. So there's substitute, combine, adapt, modify, magnify, put to other uses, eliminate. So those are all things, strategies that you can use when you're brainstorming different solutions for that, reverse and rearrange. One other brainstorming session that I like is the 635. And one of the strategies here, I mean, it's important to really think about how to manage a brainstorming session as well, to be able to make sure that everybody can contribute to that brainstorming. And then how are you going to capture it? This one, everybody writes down 3 ideas. There's a group of 6. And you're actually silent with this. So this allows everybody to have voice, even those, so it's not dominated by 1 or 2 ideas. And you're really not evaluating the ideas, because often in a kind of verbal, oral brainstorming, it's easy to go, oh, that won't work, to do that. But if you use a strategy like this, you write down the ideas, you can respond to the previous ideas or come up with new ones. So it's been a very effective way we found to facilitate some of the brainstorming. And then you keep passing that sheet around till it's reached everybody. Okay. Other great strategies, and we have a set of these cards, are these design heuristic cards. And I always feel like I'm not very good at ideation, but these cards have been they help me tremendously in being able to come up with a lot of new ideas. So what the cards do is they're based on analyzing what industrial designers have done and synthesizing, kind of come up with the 77, 78 different strategies that they found used in practice in industry. And what they do then is they present the general idea of what it is. So this would be that you apply an existing mechanism in a new way, which is a general strategy. And then they show how this has actually been done in practice. So the cards are really effective, or I find they're very effective at being able to help elicit a lot of new ideas for that. They are probably more useful for product design versus maybe, software design, or process design. But anyway, we do have sets of these that you can use in doing your brainstorming or kind of innovating or coming up ideation, more ideas for that. So after we've come up with a whole bunch of ideas, how do we start to make decisions then? So one of the strategies that we can use to help with that is a decision matrix. How many have seen decision matrix before? Okay, a few. All right, so basically this helps to categorize and help to organize the information in order to make a more informed decision for that. So basically, you have a table here, and you have the different criteria by which you're making comparison. And then you actually weight those different criteria. Some might carry more weight than others. And then you actually evaluate each of your ideas, whatever that score is, you multiply it by the weight, and then you add them up and you come up with overall scores. So in our decision matrix, if we're trying to use this to probably narrow maybe a variety of different ideas, what should we use for the criteria if we're going to do that? Specifications, yep, that's it. So you just develop these specs, right? This is how you're going to know whether or not your product meets its needs. So how should you evaluate and choose, narrow? You should use your specifications here. So an example of this, say you've got a job offer from IR, and you got multiple job offers from 4 different companies. You told them about your work in EPICS. They were already so excited about what you were learning that you got 4 job offers, and you're trying to figure out which one of these should I choose. So you identify, so we don't necessarily have specs to draw from, but you identify 1, 2, 3, 4, 5, 6 things that you think are important criteria in making your decisions, and you weight them. So location is most important to you. And then you evaluate your 4 different offers, and you come up with these total scores. See, the weight is multiply the score by the weight, and then you add them up to get the totals. Okay? So what would you do if you came up with this information based on your job? How should you use information from a decision matrix? Is it clearly company A? Maybe, maybe not. So we don't really have, we're not specific enough to always be able to, there's error in some of our assessment here. So we use this to guide us in our overall decisioning. So we could probably maybe eliminate company D and may want to seek more information between A and B to determine which one's actually best. Or really, now you can't do this with a job, but in design, it is best to actually maintain 2 or 3 options as late as you can in the design process and not making those decisions. Don't eliminate things too early in the design process. So if I would probably at least keep options A and B open and get more information, continue to develop them, because it may turn out in the long run that B is actually your best option. And if you can afford to keep C on the, being considered as well, I would recommend that. Okay. Once you have a general strategy that you've gone up with the conceptual, then you get into detailed design. And these strategies, a lot of these strategies are very discipline specific. So I'm not going to talk about necessarily how you would implement this for ECE or ME, but there are some of the strategies or tasks that do apply across disciplines, and so we're going to talk about that. Part of this is that you're taking those conceptuals and you're doing a lot of the more detailed design, as the name implies, to make sure that it's actually feasible, to understand very specifically, for example, maybe current requirements or the overall lifetime, like your battery life, very specific kinds of things that you can start to develop there. So one strategy in this detailed design that applies across is a DFMEA. So it's Design for Failure Modes Effect Analysis is what it stands for. And what you do is you actually brainstorm early in your design all the potential ways in which it can fail and see if you can actually then design a strategy that will help mitigate that risk. There's actually failure modes analysis that can be done to a variety of different things. So you can actually look at your schedule and do a risk analysis to say, what is it that's most likely to fail in my project timeline, and address that. But specifically, a strategy for design is the DFMEA. This is something that industry uses a lot. To be able to talk about this in your design reviews is very important to do this, because you actually want to figure out how to mitigate those risks as much as possible. So what you do to kind of be able to prioritize those different risks is you identify them, and then you rank them on 3 different criteria. What is the severity of what if it occurs? How often is it likely to occur? So maybe it's very severe, but it's not very, very likely to occur. And how well can you detect it? Because those that give you warning signs are less likely to be at risk than those that might fail without any kind of warning. So are you able to anticipate or detect whether or not that failure? You multiply the 3 of them together and come up with the RPN, and then you prioritize and develop an action plan. And you might identify that some of them are really not posing a very large risk at all, and you don't need to do anything to your design, but you absolutely would probably want to address those that have the highest RPN, or at least be able to defend your design decision to your design reviewers, to your future teams, on why you did not do this. So this was actually looking at, it was a washing machine sensor. What if the sensor that tells you your tub is full on your washing machine, the water, fails? It's going to keep putting out water, right? Not a fun thing to happen. So what could you do to the design to add something to that? So they talked about doing yet another sensor related to that. So you have a fail-safe, a backup for that. This applies even to software solutions. If your server, is inaccessible, if there's something that goes down, the team that was developing the EPICS system before, relied on the authentication process of Purdue. And what if that wasn't available? What were some other strategies that could be done? And could they actually then built in other strategies that could be used to address those kinds of things? So even though it's often looked at for product design, it's absolutely something, especially in this kind of environment where software is often at risk, then to be able to take a look at that. Another part of detailed design is user testing. And so there's actually data that supports kind of how many users you should involve in the user testing. And so based on, they were identifying how many bugs or problems that were found by the number of users. And if you look here, kind of about a sweet spot or, point of diminishing return is about 5.